All right, so we want to find the derivative. For this one, I do have a square root. Since I know that taking the derivative of square roots, it's often easier, well, it is easier if we first change this into a form that we can deal with. So I'll change the cube root to 1/3. Now, with having 1 over x to the 1/3, that is something that I could do with a chain rule. I'm just looking at the different parts here. But there's other things that I can manipulate within this one that might make it a little bit easier. So one of the things you want to do when you look at a question is, before you go in and do the derivative too quickly, is just look and see, is there anything else I can manipulate? Because when we have things as just straight powers, the derivatives are easier than when we have divisions and things like that. And one thing to always look for is ideas with negative exponent. So 1 over x, can you see that that's the same as x to the minus 1? And then if I have x to the minus 1 to the 1/3, that's just the same as x to the negative 1/3. So I do all this preliminary work just to manipulate things so that they're in a form that if I have to do the derivative of that thing individually, it's going to be easier. Now looking at what I have right now, if I put a dot right here in between those two functions, that's going to mean I'm going to need to use my product rule. And then looking at each thing individually, well, the one on the right, now that we've changed it, is an easy thing to do the derivative of when we have to do that. The one on the left, can you see that it has a chain rule? That there's a function inside of a function. But that's not going to be too bad either. So we're going to do our derivative now. Start far left-hand side so we don't run out of room. And we keep one of them the same, so I'll start with the second one. Keep that one the same, and then do the derivative of the first one. Well, work your way outside. Derivative would be keep the inside the same, just do the power rule first, and then multiply that by the derivative of the inside, which will be 15x to the 4 minus 1. Plus, keep the second one the same, and the derivative of the first one. And it wasn't a show that question, so this, you would be done. If it just asked you to find the derivative, you would be done here. If it was a show that question, what would happen is you would have to look for things that are in common. Can you see basically right now when you've done the product rule that you have one big term here plus another term there? So one of the things that's going to come in very handy for simplifying things is factoring. And if you look at those two things as big things, can you see that they have some things in common? Can you see that they both have x to the something over 3? So you could factor that a little bit. They also, both terms have a 3x to the 5 minus x, 3x to the 5 minus x. This one has 3 of those because it's to the power 3. This one has 4. Most likely, if this was a show that question, f prime of x, they'd probably get you to factor out the x to the negative 4/3. and factor out a 3x to the 5 minus x to the power 3. Then imagine what would be left if I did that. Well, if I took an x to the negative 4/3 times by what would give me x to the negative 1/3? That would just be an x to the 3/3, which is just an x to the 1. I would still have this 4 here. I'm not going to write anything in a nice order. I'm just going to work one from left to right now. And then if I took out an x, 3x to the 5 minus x to the 3, this would all be gone, but I'd still have the 15x to the 4 minus 1. That's what would be left from the first term. Plus, in the second term, there would still be a 3x to the 5 minus x, and there would still be a negative 1/3. Now, depending what the show that looked like in the end, you'd probably have to do some more stuff. We still have a fraction inside of here, so you might have to pull that 1/3 out in front as well. Do you want to do that? Do you want to see what it would look like most likely at the end of at the textbook, the back end of your textbook? I'm going to just rewrite this for now. I'm going to deal with that in a second. I'm going to take out the 1/3 as well. When I take 1/3 out of the 4x, that'll be 12x. When I take a 1/3 out of there, since there's a negative times a positive, that would be a negative in the end. And now we would just have 3x to the 5 minus x. So what does this look like? Well, the 1/3 would end up being a 3 on the bottom of our fraction. The x to the negative 4/3 would be the same as the cube root of x to the 4th on the bottom of our fraction, because it would be an x to the 4/3 on the bottom. The third part means a cube root, and you'd have an x to the 4. What are we left with on top? We're left with a 3x to the 5 minus x all cubed. And inside the brackets, now that our expression is quite simplified here, if I do 12 times 15, I'm going to get 180x to the 5 minus 12x minus 3x to the 5 plus x. And now there's some like terms. And now we've written a final answer that's nicely factored and has no exponents that are negative exponents or fractional exponents in the end. Of course, you might see that once you've factored it out, there's also an x in common in here. So it might have been that they factored an additional x out, or they might have left it like this.